Hello everyone, welcome to yet another math video. In this video I will be going over polynomial and rational inequalities because why not? These actually end up being pretty helpful in later math courses, mostly for the process of where you're going to be testing things to see if it's true or false. You'll see what I mean here soon. So I'll go over the process very briefly, go over a few examples. Let's get it. The process for how polynomial and rational inequalities will work, you will first need to find all x-axis related characteristics for the function, and that generally just means x-intercepts and vertical asymptotes. Then what you'll do is you will make a number line and put those x-intercept and vertical asymptote values on the number line with labels, and you'll see why you need to do that when we get to some examples. Then you'll notice those x-axis related characteristics form different intervals along the number line. So we have to test values in each of those intervals, mark them as true or false, and then we can write our answer as an interval notation. And we're done. Let's look at examples. Starting out relatively easy because I want to make sure the zeros are easy to find, or the x-intercepts. So to find that, when this is a polynomial inequality, we have to make sure that we set each of these equal to 0 and solve for x. Remember, factored form is the easiest form to find x-intercepts. So we know we're going to have x-intercepts at -1, 0. Let's see, 5, 0, and -7, 0. Or you might be able to, in some sort of online homework management system, be able to write these out just as the values here, -1, 5, and -7. Then, on a number line, what you'll do is you'll plot those numbers, right? You've got to pretend this is the x-axis. So we have to make sure they're in the correct order. -7 would be here, -1 would be here, 5 would be here, you know, maybe not to scale. And you want to label these. So I'm just going to label this as an intercept, 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 all right? You're only going to have vertical asymptotes if you have a rational inequality. And like I said, each of these x-axis characteristics, when you plot them on this number line, it'll divide the number line, or the x-axis, into multiple intervals. What you have to do from here is pick an x value in each interval. So for example, between -infinity and -7, I'm just going to pick, let's say, -8. I don't want to get too crazy here. Between -7 and -1, I'm going to pick -2. Between -1 and 5, I'm going to pick 0. If you can pick 0, pick it. If you can pick 1, pick it. Like you want to pick 0, 1, and -1 are some of the easiest numbers to work with in this whole system here. Then between 5 and infinity, I'm going to pick a number. I'm just going to pick 6. All right, so what do you do with all these values? Well, you have to test them. So this would be substituting -8 in for x in all of these examples up here. And then we just have to see if it's going to be bigger than or equal to 0. No problem. So -8 in for this x would be -8 plus 1. This set of parentheses would become -7. If you substitute -8 in for this x, -8 minus 5 more is -13. If you substitute -8 in for this x, you get -8 plus 7, which is -1, and it's being squared. So don't forget to write that square greater than or equal to 0. So let's see, -7 times -13 is +91. -1 squared is a +1, greater than or equal to 0? True. It's definitely true. So what I'm going to do then is I'm going to shade, this is how I shade, to the left of -7. And then you just repeat this process with all of these test values. So let's take a look here, -2. -2 in here for x plus 1 is -1. Let's see, -1. If you substitute -2 in for this x, -2 minus 5 more is -7. If you substitute -2 in for this x, -2 plus 7 is 5. Squared is greater than or equal to 0. So let's see, -1 times -7 is 7 times 5 squared. Oh, 5 squared is 25. Let's just write that down. 7 times 25 is 175. This is true. So what I'll do is I'll shade here as well. All right. When you substitute 0 in for all of these values up here, it's pretty simple. You'll get 1 times -5 times 7 squared. So let's see if I can do that. 1 times -5 times 7 squared greater than or equal to 0. So this is -5 times 49 is greater than or equal to 0. That ends up being a -245. This is false, so I will not shade here. And then you continue the process with 6. It ends up being true. When you substitute all of the 6 in for all of the x's up here, you get that this left side is greater than or equal to 0. So I would shade here. Now, the only other thing that you have to worry about with your interval, right? I said you can make your answer and you're done. Is you have to come up here and look at the sign you're given. And basically at this point, we're looking to see if we're going to be using brackets or parentheses. And in this particular case, since there is the little equal to bar down here, we will be using brackets. All right, so bracket here, bracket here, bracket here, bracket here. And then we can just read this off the intervals. So we would have -infinity to -7 union, -7 to -1 union, 5 to infinity. And we're almost done here. Let me see if I can, there we go. Whenever you have the same number in two different intervals, right, -7 and -7, and you have brackets around both of them, that means you include -7 in this interval and this interval. Well, if it's in both intervals, we can write these two intervals as a single interval like this. We can just say it goes from -infinity to -1. And -7 is included in this interval too, so we can just shorten it. And it is recommended, nay, it is not recommended, it is required that you shorten it. So this would be the answer for this polynomial inequality above. And again, as we move forward, if this is not factored, you need to factor before you start solving the inequality. All right, first rational inequality example. So again, you need to find all x-intercepts. Pretty simple here. The x-intercept is what you get when you set the top equal to 0 and solve for x. That means x would be 1/2. You need to find all vertical asymptotes as well, which is what you get when you set the denominator equal to 0 and solve for x. So the vertical asymptote here would be x equals -5. Go ahead and draw out your number line. Put these on here in the correct order, right? -5 is to the left of 1/2. label them. This is a vertical asymptote. This is an intercept. And again, you can see it breaks the number line or the x-axis into 3 different intervals this time. So pick test values, right? We see between negative infinity and negative 5. Maybe we pick, I don't know, let's pick negative 10 this time. Why not? In between negative 5 and 1/2, I'm going to pick 0. 0 is always nice. And then I can also pick 1 to the right of 1/2. Cool. All right, so let's see how this works. I'm going to substitute negative 10 into this function up here. So 2 times negative 10 is negative 20. Negative 20 minus 1 is negative 21 in the top, all over. Negative 10 in the denominator. Negative 10 plus 5 is negative 5, and that is less than or equal to 0. I'm always using this inequality up here. Now, this can be simplified to 21 over 5, which is less than or equal to 0. That is false. So I will not shade this area. That area does not work for our inequality. All right, same thing, picking 0. It's pretty simple when you have 0. 2 times 0 is 0. 0 minus 1 is negative 1 in the numerator. In the denominator, 0 plus 5 is 5, and that is less than or equal to 0. Again, using this inequality here. Yeah, that's true. So I'm going to come through here and shade. There we go. Lastly, I have this positive 1 over here. So let's see what happens with that. I have, let's see, substitute 1 in here. 2 times 1 is 2, minus 1 is 1. In the denominator, 1 plus 5 is 6, and less than or equal to 0. This is false. I will not use this. Cool. As we did in the last example, we have to make sure that we are using either brackets or parentheses. In this example, just like the last one, where there's an equal to, so we'll be using brackets, but only for the x-intercept. The vertical asymptote will always get a parenthesis. So it'll be a parenthesis here and a square bracket over here. The reason being, if you include negative 5 in your answer, right now with this parenthesis here, we are excluding negative 5. We say negative 5 can't work. But if you include negative 5 in the solution set of x's that work, that means you are allowed to substitute negative 5 into this fraction, and you'll get a value that makes sense. But if you substitute negative 5 into this fraction in the denominator, you'll get a 0. That's the bad place to have zeros. So negative 5 cannot be included here. This is why we're using parentheses over here and brackets for the x-intercept. So vertical asymptotes always get parentheses, is the takeaway here. The final answer would be negative 5 with a parenthesis to 1/2 in a bracket. Second to last example. In this example, I've got to do a little bit of work up front here. We need to make sure that there's a 0 on one side of the inequality. So I'll have to be subtracting 6 here. And this particular inequality, once I get it written out, will require some extra work as well. So minus 6 is less than 0. Okay. So once you have 0 on one side of the inequality, then you can start factoring and doing your number line x-axis and testing values and blah, blah, blah. In order to be successful with this example, we have to go back and use the rational zero theorem or the rational root theorem. And that is because if you try to factor by grouping, the first two terms and the last two terms, when you find a common factor, the sets of parentheses, the binomials that will result from the common factors will not match. And you can't factor by grouping. So what do? You have to create your list of zeros, and since the leading coefficient is 1, that means the list of zeros will just be the factors of the constant. So we'll have plus or minus 1, 2, 3, or 6. And those will be our x's. So again, you want to start with small positive numbers like 1 and 2. And you can go up to 3, and even 6 is fine, but I would say after 3, if it doesn't have a synthetic division that gives you a remainder 0, you'll have to go back through and start with the negatives. So let's see what happens. I'm just going to pick 1. So I've got 1, 2, -5, and -6. All right, here we go. 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -5 plus 3 is 2. That's -2. 1 times -2, I don't think this is going to work. Yeah, this is not 0. All right, let me cheat here. I can erase. I hope you have the ability to erase, or just move to a different spot on your paper. All right, let's try 2. 2, bring down the 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. -5 plus 8 is 3. 2 times 3 is 6. Oh, right, we got a 0. So what do we know? We know our zeros are x equals, what was that, 2? That was this value here. From there, we can, take this answer down here, interpret what that means. That would be 1x squared plus 4x plus 3. I'm going to factor that off to the side here. So I've got x squared, and again, it would equal 0. So I've got x squared plus 4x plus 3 equals 0. That factors to x plus 1, x plus 3 equals 0. So that means my other two zeros would be x equals -1 and x equals -3. So I've got -1 and -3 in my list here. All right, off to the number line and rinse and repeat. So let me just do this, there. Make sure you write them in the correct order. I've got -3, I've got -1, I've got 2. And this breaks my number line. Oh, and these are all intercepts. So let me write that, intercepts, or zeros, if you will. All right. Let's see here. Pick test values. So I'm going to pick -4. I'm going to pick -2. I'm going to pick 1, and I'm going to pick, actually, I want to pick 0 here. And I'm going to pick 3. From there, you want to test all of these values. I like to go back to the original function, or the original inequality, just to make sure I didn't, in case I did any math incorrectly, at least I can get the interval answers right here. So I'll go through and do 1, just so you can see. It would be -4, let's see here, all right. -4 cubed plus, what is that, 2 times -4 squared minus 5 times -4 is less than 6. So this is -64, this is 32, this is a +20 is less than 6. Let's see, that's 52 minus 64 is -12 is less than 6. That's true. So I'm going to shade here while I remember. And then you'll go through and rinse and repeat for all of these other intervals. And you'll get a, a number line that looks like this. You know that you'll be using parentheses here because you have what a less than, so you're using parentheses. There we go. And you can write out your final answer then pretty easily. It's going to be negative infinity to negative 3 and negative 1 to 2. Last example, got to find the x-intercepts, have to find the vertical asymptotes, and again, you want to make sure that you are keeping track of what those are. Let's make this greater than or equal to, just for funsies. So the x-intercept here would be 0, 0. That's what you get when you set the top equal to 0. The vertical asymptotes, on the other hand, are what you get when you set the denominator equal to 0. So x squared minus 25 equals 0. You can factor by using the difference of squares, or you can solve this by using the square root property. Either way, you'll have two vertical asymptotes, one being x equal to 5 and the other being x equal to negative 5. And I don't know that I said this, maybe this will be a reminder, hopefully. Every vertical asymptote requires its own equation. You don't write x equals 5 and negative 5. That will not cut it. Okay, so let's take a look at the, what is this called? The number line. So we've got negative 5. That's a VA. We've got 0, which is an intercept, and you have positive 5, which is another VA. Testing values, about negative 6, negative 1, positive 1, and positive 6. Seems good to me. Do your testing again. I'm going to test this interval here. Between 0 and 5. So you substitute 1 in for x, 1 squared minus 25 is greater than or equal to 0. So this is 1 over negative 24 is greater than or equal to 0. This is false, so I'm not going to count this interval. And again, you can see the intervals here based on where the zeros and vertical asymptotes are, the x-intercepts and vertical asymptotes are. And then you just do this for every other interval. And it turns out that this one will be false, this one will be true, this one will be false, we saw that, and this one will be true. So here it is. True, true. But again, I changed it at the very last second to equal to. The equal to only applies to x-intercepts. So this particular x-intercept here will be equal to. Any vertical asymptotes are always going to have parentheses. So your answer here, negative 5 to 0, union 5 to infinity. I know those last couple examples were quick, but it's just a lot of calculations that I know you can do. I have confidence in you that you can make those little calculations and then compare it to the number 0. So yeah, I hope this makes sense. Thanks for watching, and I wish you all luck.